All right, very good. Okay, Assalamualaikum and good evening, everybody. I would like to welcome our distinguished speaker, Dr. Muhammad Nurul Azmi. Thank you for joining us today, Dr. Azmi. I would like to introduce our speaker to my dear students. Dr. Muhammad Nurul Azmi is a senior lecturer from University Science Malaysia from the School of Chemical Sciences. He obtained his PhD from Ecole Polytechnique France. Yeah? His area of expertise are natural product chemistry, organic synthesis, medicinal chemistry, and pharmacognosy. So today he will be giving a lecture on carbonyl condensation reaction of Michael reaction and Robinson annulation. So students, please pay attention. Dr. Azmi, the session is yours. Thank you very much.
I think you can hear me. Okay, students, I think we have around 55 participants for today. Thank you very much for joining this session. So let me share my slide. Voilà. Oh, alors. And after that, no, sorry. Okay, you can see my slide there. Okay.
Yes.
So, okay, Bismillahirrahmanirrahim, and Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everybody. And thank you, Dr. Vicky, my seniors actually from University Malaya previously, and also Dr. Hidayah is also my senior in UM during that time. So my name is Muhammad Nurul Azmi, and Muhammad Taib, and I'm a researcher and also lecturers from School of Chemical Sciences, University Science Malaysia, in Island Penang. So, and for today, it's not teaching, I'm just sharing the thing that I have done in my research. And the title have been given to me is Carbonyl Condensation Reactions, which is focusing on two reactions, which is Michael reactions and also Robinson annulations. I already give Dr. Vicky about the slide today, this morning, and I hope you received that one. And also some additional material that you, if you're interested to do so, so you can make extensions reading respective this topic. Okay, so this is my lab in USM, and also this is my lab and my school in USM. And some introduction about myself. Okay, as Dr. Vicky said, I'm a trained organic synthetic chemist since 2012 from École Polytechnique. Okay, it's a military university in France. And also my another PhD is in natural product chemistry, which is from University Malaya during that time. And also I'm working with IFAM as a research fellow, and also UM, of course. And I'm also the adjunct professor in Universitas Padjadjaran Indonesia. And that's all, nothing much about myself. Okay, I'm a normal person as you all. So, and this is our school. It's built 1969, so it's quite old building. And anybody from the northern areas, welcome. If you want to come and visit USM, please come and contact me. Don't worry, I will be a road tour for everybody here. Okay, some introduction about my research. I'm doing natural product as usual, and including pharmacognosys, because natural product and synthesis cannot stand alone. And after that, I'm doing total synthesis of natural product also, and together with heterocyclic chemistry. Along the way with total synthesis and also heterocyclic chemistry, I'm doing also the method development in terms of organic synthesis. So let's go to the serious business. Okay, so I've been given the title about condensation reactions between two carbonyl compounds. Okay, and in this topic, okay, I just want to highlight the condensation reactions between two carbonyl compounds. It means if they say it's about the condensation reactions, they will have two species here. The first one is enolate, and another one is enol. Okay, These elements or this compound can be react with another component carbonyl compound to form a new CC bond. Okay, and in these reactions, okay, one carbonyl component serve as a nucleophiles. If you heard during your under first level, if I'm not mistaken, you will learn about the electrophile and nucleophile, and you will learn again during along the way with your studies if you study in organic chemistry. So you will see nucleophile and after that electrophile, and nucleophile, which is electron rich, will attack the electrophile. Okay. So each case, okay, new bond are formed at the alpha carbons, which is you already learned before. Okay, one of the reactants is the carbonyl group of the others. And this, the presence of action of living group on the electrophilic carbons determine the structure of the products. So in this kind of topic, you will learn about roughly around 5 types of reactions. I think Dr. Vicky and also Dr. Hidayah already covered 3 of them. And for today, we're just focusing on microreaction and Robinson annulations. And again, if you want to know and recap again what is the enolates, okay, this is the enolates, which is very reactive species. We classify as a nucleophile. Okay, if you are first year students, I think you will learn this one during your second topic of this organic chemistry. And this one is an electrophile, and we see clearly this is carbon deficient. If we talk about the electron cloud here, the electrophilicity, okay. Wait, I have to change to. If we talk about the electrophilicity, so you will see this carbon is the carbon deficient and easily to nucleophile attack this part, okay, to give the new CC bond. So for the condensation, as I said, for condensation reaction between carbon compounds, they have 5. The first one is the aldol reactions, which is a very famous reactions. This is reaction will give you beta hydride carbonyl compounds. This is kind of an examples reactions. They have a lot of variety of reaction, which is represent those aldol reactions. So the second one is the Claisen reactions. The Claisen reactions will form beta ketoesters. In this case, they will have a formation of the new double bond between two carbonyl groups. And next, what we have to do, we have to understand about the Dickmann reactions. It's intermolecular reactions, which is, for example, this is 1,6 diester. And after that, they are doing cyclization to form this kind of compounds. Okay, for myself, for today, we will do microreactions and Robinson's annulations. So for the microreactions, okay, it's involved 2 carbonyl components. Okay, anybody who have lecture notes, you can highlight here. It's involved 2 carbonyl components and the annulates of 1 carbonyl compound and the alpha unsaturated carbonyl compound. So for the microreactions, they have 2 elements there. The first one is annulates, which is nucleophile. You can write here is nucleophile. I'm not sure my pen is working or not, so I have to check again. Ah, it's working. Okay, so I should change to the pen. Okay. Oh, okay. So this one will be a nucleophile. Okay, and of course, for the microreactions, they should have the alpha beta unsaturated carbonyl. This is the alpha beta unsaturated carbonyl. What do you call alpha beta unsaturated carbonyls? What do you call alpha beta unsaturated carbonyl? So this is the alpha position, and this is the beta positions. So that's why they call alpha beta unsaturated carbonyl compounds. So recall that, we have to recall that alpha beta unsaturated carbonyl compounds, it's a resonance stabilized. First year you have already studied about the resonance stabilized. It can be and have 2 electrophilic sites and the carbonyl compound at the beta carbon. So they have two resonance structures in this, and if we change to the resonance hybrids, it's become this one, which is have the two resonance, two electrophilic site, which is carbon diffusions. So in this case, you will learn also about the Michael donor or Michael acceptor. So I want to pay attention about the Michael acceptor. The Michael reactions involve the conjugate additions, which is 1,4 additions of the resonance stabilized annulates to the beta carbons. So previously we already learned to the beta carbon, which is this side, okay, and of the alpha beta unsaturated carbonyl systems. The alpha beta unsaturated carbonyl components is often called Michael acceptor. Okay, so in this case, we already have alpha beta positions, and usually the reaction happen in these positions. Okay, so this is Michael acceptor. Meanwhile, this one is a donor. Problem with my comp, and this one is the donor. Okay, so for example, these kind of reactions, okay, when they are doing micro reactions, they will form a new CC bond at the beta positions. Okay, as I said, this one is coming from the Michael acceptor. Okay. And this one is coming from donor. Okay, so again, if this is the cyclic systems, if there are cyclic systems, this one is the Michael acceptor, and this one is the Michael donor. Again, they will make a new bond at the beta positions. Okay, why we call beta positions? This one is the alpha, this one is alpha, and this one is the beta. Okay. So the mechanism for the micro reactions, it's involved. Okay, the base, we remove the proton on the carbon between two carbonyl groups to form annulates. Okay, so of course, the donor will do some move. Okay, and after that, this one is the nucleophile. This is the base. Will extract the most acidic proton. In this case, this is the most acidic protons. In this case, this one is the most acidic proton. They will extract the protons and make this one is a carbon. It's a nucleophile. And nucleophile will attack, as I said, micro reactions will attack at the beta positions. So this is alpha position and this is beta positions. It will attack this carbon diffusions, okay? And after that, doing nucleophilic additions of the annulate at the beta carbons, which is this one, and form a new CC bond and another annulates will form, okay? And after that, they are going to the protonation reaction. So this one is nucleophilic additions. Anybody who have pen, you can write here, nucleophilic additions. Okay, I will try again my pen, but I'm not sure it's working on it. Nucleophilic additions, and this one is a protonation. Okay. So this is very simple mechanism in terms of micro reactions, okay? Because the Robinson relation is the combination between two reactions. So for the micro reaction products, okay, when the product of the micro reactions is also a beta ketoesters, okay, and it can be hydrolyzed and decarboxylate by heating in aqueous acids. Okay, so this formed 1,5 dicarbonyl compounds. and also 1,5-dicarbonyl compound as a starting material for the intramolecular alterations. And why they call 1,5-dicarbonyl compounds? Because they have two carbonyl groups, okay, at the position 1 and 5. 1, 2, 3, 4, and 5. That's why they call 1,5-dicarbonyl compounds. Okay, so for this kind of reactions, how they are doing mechanisms, okay. I'm sorry, my pen is problem, so I cannot draw the mechanism. So they will start to do decarboxylation first, hydrolyze first, okay, and after that proceed with the carboxylations to give the byproduct, which is carbon dioxide, and also tautomerizations, because in this process to convert into these structures to these structures, there will be a ketoenol formations. As we know, enol is not less stable compared to the keto form, so they are proceed with the keto forms. Okay, so I just give you the general reactions about this one. So otherwise, if my pen is okay, I will draw the mechanism, but the problem is it's not okay now. Okay. Okay. This topic is very simple. We just finished about the microreactions. So we have a few questions that we can do. So I already give you the question in the lecture notes. So if you have a time right now, maybe we can do it together. Okay, about this one. So please, I give you around 5 minutes to do it, and after that we will do it together to solve the question 1. Okay, so I will stop sharing. Okay, you have the question, right? Dr. Vicky already give the questions to the students.
Yeah, already.
Okay, so
They have the both file.
okay, perfect. So 2 minutes for examples to do the exercise. Okay, the questions ask you about which of the following compound can serve as a Michael acceptor. So as we know, the Michael acceptor is the compound can have a alpha beta positions. This is the keywords. Okay, alpha beta positions. So from these 4 compounds that we have here, okay, for the 4 compounds that we have here, so we can know which one is the Michael acceptor. Okay. So for this one, okay, the Michael alpha, as I said before, Michael acceptor is an alpha beta unsaturated covalent compounds. So if we refer to compound A here, so they have the alpha beta unsaturated. So this one is the Michael acceptor. Okay, for A is the Michael acceptor, and for B is not Michael acceptor because they are not alpha beta unsaturated. Because this one is the at the beta and also gamma positions. Okay. Meanwhile, C is also not the alpha beta unsaturated. Okay, because they should have the alpha position, which is this one, alpha and also beta positions. And then lastly, this one is the alpha beta unsaturated. Makes this one is the Michael acceptor. Okay, so in these reactions, if we said about the micro reactions, they should have enolates and also alpha beta unsaturated carbonyl groups. So this is the keywords for microreactors and microreactions. Next questions. Okay, what product is formed when each pair of the compounds is treated with sodium hydroxide, okay, in ethanol. Okay, so we have two elements here. The first one is the cyclic systems, both of it cyclic systems. So you have to determine which one is the beta positions. Okay, so the new bond formed at the beta position, as I said, this is alpha position and this is beta positions. They will have a new bonds in at beta positions. Okay. I'll try again if I can use my pen. So this is the answer for that. So if I can use my pen, sure. Okay, try. So we will have this one. Okay, we have acidic proton in these positions. Okay, so we have this base. Okay, we'll extract this proton and give this one and transform into nullets. Okay, so oh, very good. Have to erase it to draw the something like this. Okay, so there will be protonations. From ethanol and finally give you this product. So the keyword is for the micro reactions, it will form a new bond in this position. Okay. So next for the second ones, okay. So the second one is a similar, so alpha beta unsaturated carbon group. So this is the alpha positions. This is the beta positions. Okay. So for the beta positions, they will make a new bond in these positions, and after that give you this kind of products. Okay. So for this kind of subjects, okay, for especially in organic synthesis, you have to do more exercise about it. Okay, and make sure you understand what you are doing. Okay, so for the second mechanism, so what they have done is the first one they are doing annulate formations. Okay, as I said, for the annulate formations, this is the most acidic protons. Okay, we'll extract the proton here and give back to this carbon. Okay, in this time, this one is the enolates will attack the carbon division in these beta positions, and after that give you the products. And lastly, they are doing protonations. Okay, protonations here, and give you the target compounds. So make sure you understand about the mechanism to get the final products. Okay, let's move to the next questions as I prepared. Okay, in this case, we are doing reverse way. Okay, what is the tank material needed to prepare each compounds using micro reactions? So again, you have to understand these micro reactions form from enolates and also alpha, beta, and saturated ketones. So we can do some conclusions with these starting materials. Okay, so for this one, if you are doing cleaving in these positions, if at this, okay, cleaving in this one, so leave at this one, so you can separate which one is a mechanical acceptor and which one is a donor. So this one is the acceptor, this one is the donor. Okay, again for this one also, so if you are confused, you can make it into skeletal structure for these functional groups. Okay, so and you will see clearly this one is the breaking point for these elements, which is enolate and also alpha, beta, and saturated ketones. Okay, and the last one for this one, it's easy because we have the alpha, beta. It should have alpha, beta. This is alpha positions, and this is the beta positions, and the breaking for the new bond formation, which is in these positions. Okay, so I hope you can follow this one. Okay, to make sure you understand about the micro reactions. Anybody you have question before this? For this, anybody you have question for this before we proceed for the last assignment? No, okay, it's okay, I can proceed. Okay, thank you, Natalia. Okay, so for the last question for micro reactions, how you convert into cyclohexane to compound below. So in this case, we are doing retrosynthesis. So as I said, it's similar like like previous questions. You have to propose what is starting materials. Okay, in this case, they will have two elements here. The first one is the okay. The first one is the enolates. Okay, and the second one is the alpha beta. And saturated carbonyl. Okay, in this case, you have alpha, beta. Okay, so there are probably you will come out with into two answers. Okay, so maybe this part will be the this part will be this cyclohexanes will be the enolates, and this one will be a acceptor. Okay, so or you can change, but the problem is for this question they have only one answer. Okay, which is this one will be the this one will be the enolates, and this one will be the acceptor. Okay, if you want to change, okay, for examples, you want to be this one as an acceptor. Okay, if your answer is like this, you insist you want to do as an acceptor. Okay, okay, plus okay, for example, like this, okay, because this answer is wrong, because you cannot get this one because they are coupling at the alpha position. So you have to change your answer, become this one is become enolates, and this one is become receptor. Okay, so yes, so it's become enolate and this one is become receptor. I hope it's clear, okay, because you cannot change this one to accept this one into acceptor and this one into enolate, because the coupling is happen in the alpha position. So you have to change. This one is the enolates and this one is the acceptor. Because if you remember the mechanisms, we should draw the mechanisms. So this is the most acidic proton, for examples. Okay. We'll extract the proton here, and after that, okay. So this one will attack this one, this carbon, and give you this one. And after that, they are doing protonations. We give this product. So you cannot do this synthesis route to get this product, because in the end, this one will give you at the beta positions. The product will be this one. Okay, not this one. Okay, so I think we already finished the Michael additions. So Michael addition doesn't cover too much in this slide, because it's just an introduction about this one. So next, move to the Robinson annulations. Okay, so for Robinson annulation reactions is the ring formations. Okay, so for the Michael reaction, it's just a coupling between beta position at the beta positions between enolates and also alpha beta unsaturated ketones. And for the Robinson annulation is the formation of rings that combine microreactions with the intramolecular interaction. So they have two reaction happens. The first one is the microreactions, which is the coupling at the beta positions that we learned before. And the second one is the intramolecular interaction, which is, I believe you already studied before. Okay. So the starting material for the Robinson's annulation is the alpha beta unsaturated carbonyl compounds, similar like Michael, because the first one they are doing micro reaction first, and also they should have the enolates. Okay, so for this one we have alpha beta unsaturated carbonyl compounds, and after that the carbonyl compound that form the enolates, and reactions have form in the base. They need base to form enolates, and after that, in this case, they are using they are formed two new sigma bonds, which is on the top. This one, this is the new sigma bonds, and the bottom one, and also one new pi bonds. Okay, so for the Robinson annulations, it's form a 6-member ring. Okay, 6-member ring only. And there are 3 new CC bond, as I said before, 2 sigma bond, 1 pi bond. And the product contain an alpha beta unsaturated ketones. In this case, for example, we have example here. This one is alpha beta unsaturated ketone. Okay. In the cyclohexane ring, there is a 2 cyclohexanones. Okay. This is 2 cyclohexanone groups. Okay. Cyclo is a cyclic, hexane is 6-member ring, ONE is a ketones. So to generate the enolate components, the Robinson annulations needs a base, for examples, okay? For example, there has OH base in water, and also ethanoates in ethanols typically used for these reactions. So for example, this is, as I said, there's form 6-member rings. There are also form a new sigma bonds, which is 2 new sigma bonds and also 1 pi bonds. Okay. So this is an example of the Robinson annulation reactions. So for the mechanisms, Robinson or annulation reactions, as I said, they have 2 mechanisms involved. The first one is the Michael additions, and the second one is intramolecular aldol reactions. Okay, so for the transformation from number 1 to number 2, okay, base, okay, this is the base. Okay, if you have a pen, you can label this one as a base. We've removed the most acidic proton. In this case, this is the most acidic protons. And the proton between the two, which is proton between 2 carbonyl groups. If we talk about these elements, okay, to form enolates. In this case, and after the base removing the most acidic protons, they will give you the enolates, okay, the nucleophile. And the conjugate addition of enolates to the alpha, beta unsaturated ketones, okay, the enolates will attack the beta positions. Okay, if you have pen, you can put alpha and beta here. They will attack the beta positions to form the first sigma bonds. Okay, and after that, during that time, they are form another enolates. This is the second enolate. This is the first enolate, and after that, they form a second enolates. And in this time, there are protonations of enolate form a 1,5-dicarbonyl compounds. Why they call 1,5-dicarbonyl compound? Because this one is a 1, 2, 3, 4, and 5. This one called 1,5-dicarbonyl compounds. And next, the reaction is not stopped there. They are moved to the second mechanism, which is intramolecular aldol reactions. In this case, the base, during that time, the similar base that we use, okay, we remove the proton in these positions and form another enolates, and we'll attack the carbonyl group to form the second sigma bonds. In this case, they are formed a second sigma bond. This one, they are formed the first one, and this one, they are formed a second sigma bonds. And again, protonation happened during that time to form beta hydroxycarbonyl compounds. This is the beta hydroxycarbonyl compounds. Okay. And last ones, okay, of course, the reaction is not stopped there. The hydration happened, okay, the hydration of the beta hydroxycarbonyl compounds may happen during this kind of process, okay, by following 2-step reactions, E1CB, which is eliminations unimolecular conjugate base mechanisms. Siapa ada pen, pensel, tulis, eliminations unimolecular conjugate base mechanisms. And during that time, there are loss of proton to form the enolates, okay, and eliminates OH form a pi bonds. So in these mechanisms, they will form 3 bonds, 2 sigma bonds, 1 pi bonds, okay. They will form the first sigma bonds by doing micro reactions, and second sigma bonds by doing aldol reactions, and last one during the dehydrations, they will give you another pi bonds. Okay. So they have the question how to draw the product of Robinson annulations. And to draw the product of Robinson annulations without writing out the entire mechanism, because they have involved 3 mechanisms. The first one is Michael additions. the second one is intramolecular aldoration, and the last one is deprotonation. So it will take your time. If the question asking during your exams, draw the product for the Robinson annulation. So this is how you can practice. Okay. So first one, you have to place alpha carbon of the carbonyl groups. Okay, that become enolates next to the beta carbons to the alpha beta unsaturated carbonyls. So this one is the alpha beta unsaturated. Okay, you have to form like this in these positions. Okay, put the alpha carbonyl on the top, close to the beta carbonyl groups. Okay, and the second one, join the appropriate carbon together as shown. Okay, you have to join together as shown here. If you follow this method, the drawing with starting material, the double bond in the product always end up at the same position of the 6-member ring. Okay, so because Robinson annulations involve the formation of 6-member rings, I strongly advise you draw in these positions to make sure you are drawing the correct products. Okay. Okay, this is an example. What is the starting material needed to synthesize the following compound using Robinson annulations? The first one, as I said, locate the cyclohexane non-ring and redraw the target molecules if necessary. Okay, and to most easily determine the starting material, always rearrange alpha and saturated carbon system in the same locations. In this case, you have to flip the ring, okay, to make sure it's become like this, okay. And the target compound may have to flip or rotate, okay. They have two options. You have to rotate or you have to flip. In this case, you have to flip. And you must be careful not to move any bond to the wrong location during the process, okay. The funny thing is, for the students, if you want to do propose some of reactions, sometimes you are missing the substitution, for example. So, for example, methyls or methoxides. So be careful when you are doing the retrosynthesis. Make sure all the substitution exists similar with the given structures. Okay. So in this case, you have to flip the compounds into this position. So as I said, like these pictures. Okay. So the second ones break the cyclohexane ring into two components. We know that they have alpha beta unsaturated ketones, carbonyls, and the one is annulates. So you have to break it. Okay. First, break the CC bonds, which is this one, into half, become the carbonyl groups and also enolate components. Okay. And the second one, break the bond between the beta carbons. Okay, this one. First, you have to break this one, and the second one, you have to break the beta carbons and the carbon which is bonded. So in this case, okay, after you bonds, you break this one, these positions, and these positions. Okay, let me check. Pen. Okay, first you have to break in these positions and these positions. Okay, okay, pen. And after that, you add sigma bonds, pi bonds in these beta positions, and you add atom in the double bond here. So you will get the two components for Robinson annulations. Okay, so I already give you some questions to discuss. Okay, so maybe I will give you around 2 minutes, and after that we will see the answers. Okay, so we can start now, hopefully. Okay, I will stop sharing a little bit. For these Robinson annulations, we have around 3 exercises. Okay, just to know how we can do retrosynthesis. Okay, and my pen is not working, so I think you can do by yourself about the mechanisms. If you need me to draw the mechanism, I'm happy to do so. I will draw on the paper and I will give it to you, okay? Stop sharing. Okay, we are doing the exercise now. So I think this is the last part of it. If we can finish around 20 minutes, maybe, okay. So for the question one is which of the following bicyclic system can be prepared by the intramolecular Robinson annulations? So this this question asks you to give the starting materials to perform these bicyclic compounds. Okay, so this is the answers. Okay, so Robinson annulations form a conjugate cyclohexanons. The conjugate cyclohexanon in this one. Okay, conjugate cyclohexanon is this one. Okay, this is what we call conjugate cyclohexanons. Okay, this is what we call conjugate cyclohexanon. Conjugate cyclohexanon. Okay. Okay. So in a bicyclic product, one carbonyl, which is C double bond C, must be shared with the both rings. So for this one, this one. Okay. For this ones, okay, this is the yes. This is can be prepared by Robinson annulations. And as I said, we already learned how to do a disconnection approach. So this is the enolates. This is alpha beta unsaturated ketones. And meanwhile, this one is the enolates. Okay. So we have to do more practice about this one. So spend more time for this. Okay. Okay, so kejap betul penting. Okay, so for this one, this is the you can break to this carbon. Okay, so for the B, this is no this compound cannot be synthesized by Robinson annulation because as I said, one carbon of a C double bond must be shared by both rings. So this one is not sharing a both ring. Okay, if we see here the positions, the new bond is formed into the 1, 2, 3, and 4, which is 3 and 4 positions. Meanwhile, this one formed into 1, 2, and 3 positions. So this one cannot be formed by doing Robinson annulations. How about C, these compounds? Okay, C can be synthesized by Robinson annulations if we do retrosynthesis carefully. So you can find this is the connection, disconnecting areas, okay? And again, you should have two components in this case. The first one is the alpha beta unsaturated ketone, this one, and this one is the enolated elements, okay? And lastly, okay, and lastly, this is the wrong position for carbons, even though they are sharing the double bond, but because they should have the alpha beta position, usually they will have in this double bond should have in these positions, not these positions. Okay, so when you get this kind of question for examples, take your breath okay, analysis one by one, okay. So it will help you alone. Rather than doing mechanisms, it will take a lot of time because it involves three mechanisms, which is the first one is microadditions. You have to spend a lot of time to do that. And after that, alderations, and lastly, deprotonation. So this is the simplest approach how you can determine the starting material for these compounds if they are positive for the Robinson annulations. Okay, next question is, okay, draw the product of each Robinson annulations from the given starting material using OH in H2O solutions. So the question asks you to produce this, the products. And because they already mentioned the Robinson annulation reactions, okay, when they mention Robinson annulation reactions, they, of course, they will form a six-member ring, okay? So when they are doing that, so you have to come up with the products. The base already mentioned there's OH and also in water. So this is the products, okay? Again, you have to by referring the lecture notes that are given to you, you have to rearrange, okay, the alphabet and enolates into these arrangements to help you to synthesize the six-member rings. Okay, for this one is the first products, which is formed by Robinson annulation reactions. Okay, and for the B, it's the question asks you like this, and after that you have to redraw to perform the structure like this. If you see the lecture notes are given to you, you should have these arrangements to make sure you understand about the Robinson annulation reactions. And after that, you can get the products. Okay. Okay, this is the last question, and after that we can finish. Okay, answer the following questions about two acetylcyclopentanones. Okay, this is two acetylcyclopentanones. Cyclopentanone is the four-member rings. Two acetyl groups. This is acetyl group attached at the carbon number 2. So the question is, draw the Robinson annulation products formed by reaction of two acetylcyclopentanone with methyl vinyl ketones. Okay, they already give you the structure of vinyl ketones, methyl vinyl ketones. And if you think this compound will give you one products, it means you are wrong. So it will give you two products. Okay, so this is the products. In this case, okay, the first one, it will react with the first products. It's happen when they react with this cyclopentanone. Okay, and the second one react when they react with this ketone. So that's why they have two products. So I already have the mechanism, but the problem is maybe I can scan and give it to Dr. Vicky for this. I hope it's okay for that. So they will give you only two products. So to do one by ones, you have to proceed with the micro addition first, and after that followed by outdoor reactions and followed by condensation reactions. Okay, so I think for more info about this kind of reactions, anybody who are interested to study in organic synthesis, these two books, okay, these two books is a very good books. This book I get from UM during my study in UM. I found this book. It's a very thick book. Anybody who needs a soft copy, I can give it to you. And also G. Jack Lee is a very good book also. So if you have a time, so I have the copy. If you want, just let me know. I can give you the copy of that. So, and I have another books, which is this one is 250 name of reactions. Another book, the recent book that I have, this one is more than 300. And the book that I get this week is around 750 reactions. in the world which is involved organic synthesis. Okay, so again, thank you very much. I'm really sorry because I don't make enough preparation for these sessions. I hope the sharing session that have been given by myself will help you a lot during your journey in UITM, especially in chemistry. So now I open for Q&A sessions. And anybody who want to keep in touch with me, please check my website and also my email there. Okay, thank you very much. Now I open for Q&A sessions. Anybody who have a question, you can ask me and I will try to answer if I can. Okay, Dr. Vicky. As promised, 1 hour lectures.
Okay, students, do you have any questions for Dr. Azmi? Don't be shy. Dr. Azmi won't bite.
Oh,
He is a
okay.
very nice person.
Biasa mekanisme ni dia lambat sikit tu. Dia kena dapat soalan dulu baru boleh buat. Saya
Ya,
akan
betul.
scan dekat ni pada saya bagi doktor boleh?
Boleh je.
Nanti
You
saya
can share
scan.
the answers to me and then I will share to the students lah.
Okay. Don't worry. Tak ada kot doktor.
Tak ada soalan. You can write it as well. Ada tak dalam ruangan chat?
Oh ya.
Ya.
Sekejap. Sekejap saya check ruangan chat.
Tak ada juga. Student ni memang macam tu, dia memang malu sikit.
Biasa doktor, USM pun sama.
Next week will be our last week, the 14 weeks, and after that, cuti, belajar, study week, and then after that, start lah exam.
Oh. Okay.
Tak ada soalannya. So, tak apalah. So, with that, again, we would like to thank Dr. Azmi for your willingness to be our guest lecturer today. So, your lecture has been very informative and very easy to understand. Hopefully, the students will benefited from that. Okay, so again, thank you very much, Dr. Azmi.
Sama-sama. Thank you for invitation. Nothing much I can prepare.
Okay, it's good enough. Alright, sebelum kita bersurai, kita nak ambil gambar dulu Wajib Cik. Buka video semua.
Bukti.
Bukti kita dah buat kerja. Okay.
Pening tak ada air doktor. Tu yang kita orang nanti akal ni.
Oh ya. Yeah.
Hari tak ada air.
Allah, kesian. Sampai bila? Jangan pergi Penang lah.
Hari
2-3
Sabtu.
hari ni.
I kena pergi ikut lah ni Kedah kot.
Okay. So, buka kamera. Kita nak ambil gambar. Ada banyak ni. Kita dah 100 lebih. So, akan ada a few snaps lah.
Oh, 100 lebih doktor. Saya ingat.
Laku kan? You punya lecture. Ramai datang. 100 lebih.
Mak
Oh, you see?
kau
This
belajar
group
ke kau
featured
main? Siapa ni? Fitri, kau belajar ke kau main?
Penuh satu monitor dengan dia, dengan kawan dia.
Yang belakang tak nampak. Belakang Fitri tak nampak.
Bukan. Kita nak ambil gambar.
Baju biru.
Azmi daripada
Alright, we will...
SM ke?
Ya doktor? Doktor Hidayah?
Daripada student USM ke? Dengar tak?
Saya student UM.
Sorry, maksud saya punya partisipan ni ada tak yang daripada USM ke, UM ke?
Saya rasa tak ada kot. Sebab ini program U bukan program USM, so I prefer not.
Okay, boleh je jemput semua kan?
Yang ni 3 orang sampai tak muat ni.
Juga.
Ni 3 orang sampai tak muat ni, Rabiatul ni.
Okay, kita start with the first group ni dulu. Yang pertama ni. Okay, senyum. Senyum je lah. 1, 2, 3. Okay, kejap. iPhone slow lah benda ni. Kejap Sabar ya. Okay. Next group. Oh, kosong. Kosonglah group ni. Tak ada nama-nama je. Tak ada gambar.
Oh, tak ada gambar, nama je. Saya pun perasan kat.
Uh-uh. Ramai ni tak buka. Tak apalah, I ambil satu je sampel tak ada gambar ni. Okay, another one. Kita tengok slide seterusnya. Ada tak orang? Tak buka gambar lah adik-adik ni semua. Semua tak buka. Ha, ha, ha.
Apalah, doktor.
Semua tak nak. Tak apalah. Okay, last one lah. Semua tak buka. I ambil gambar the last part ni je.
Okay, siapa yang dari Penang nak main USM bagi tahu. Kita cari nasi kandar.
Siapa daripada Penang angkat tangan. Sikit-sikit je lah kendaya kan. Alright, so kita balik semula ke first slide. Alright.
Okay.
Slide dah. Okay. Alright, student, thank you very much for joining the lecture. Any last nasihat for the student, Dr. Azmi?
Okay. Anybody who are interested in organic synthesis, so sebenarnya tak banyak dekat Malaysia yang betul-betul hardcore organic synthesis, to be honest. Okay, in Malaysia, nature product ramai. Okay, so if you're interested in organic synthesis, doing practice is very important, and understand the basic principle of organic chemistry. In organic chemistry, they have three basic reactions: additions, elimination, and substitutions. Just playing around with that, so inshallah you will understand lots about organic synthesis. I wish you good luck for the finals, and looking forward to see everybody's Dr. Vicky or Kak Vicky and also Kak Hidayah in your time, inshallah. Okay.
InsyaAllah. Alright, thank you semua. Assalamualaikum and that's it. Kita boleh bersurai dah lah. Thank you,
Thank
Dr.
you
Hidayah.
very much. Ala portion.
Thank you, Dr. Azmi.
Bye.
Student jangan lupa.
Thank you, doktor.
Sama-sama.
Oh ya, attendance ya. Ada attendance dalam chat
Jangan
box.
lupa attendance.
Jangan
Jangan
lupa
masalah
attendance.
tidak. Okay, doktor, terima kasih semua. Terima kasih.
Okay, thank
Okay,
you.
Dr. Azmi. Jumpa lagi nanti semester depan pula.
Topik lain, doktor.
Kita topik lain eh. Baik.
Kan saya
Okay.
bosan, stres je. Ni, risau, stres je.